The kinetics of chemistry is pretty cool. On the microscopic scale, particles are moving really, really fast. So fast, in fact, that we don't even measure them by speed. Instead, we call it kinetic energy. If something has a lot of kinetic energy, then it has particles that are moving really, really fast. If a chemical has a lot of kinetic energy, then it could even change states. I'm now going to let you in on a little secret. Kinetic energy is code word for temperature. It's not an exact translation, but it'll do for today. Water at room temperature and normal atmospheric pressure has a certain amount of kinetic energy. We add heat to the water by using a flame, your breath, even a fart perhaps. Anything that is higher in temperature than the water, just put the water next to it and there will automatically be heat transfer due to the second law of thermodynamics. That's a bit above and beyond though, so don't worry about that for now. Once enough heat is added, the water will go from a liquid state to a gaseous state. That's kinetics in action! The reason a state change happens is because the molecules gain enough kinetic energy to overcome their intermolecular forces, or IMFs. But that's a whole other can of worms for a whole different day. Basically, there are 4 main types, and they each have varying levels of strength, and this is why things stick to themselves. Until there's enough kinetic energy transferred due to the second law of thermodynamics to overcome the IMFs, and then a phase change happens. Okay, so now that we're on the same page, let's talk reactions. In order for reactions to take place, there are a couple boxes that need to be checked. Simply put, is the stuff moving fast enough? And are the things hitting each other in the right orientation? That's a lot of really cool chemistry, but we don't have time to talk about that. Now, a reaction rate is how fast those boxes are being checked. Each reaction has its own reaction rate based on specific circumstances and whatnot, but all you need to worry about is the fact that it's a thing and it's really important for a whole bunch of reasons, like companies getting the right yield of products, or if my reaction is going to finish in time for that really important thing I need to go to. Anything, really. Here's the cool part. There's these things called catalysts. They can affect the rate of reaction. Now, in order for something to be considered a catalyst, it needs to go in with the reactants and then come out on the product side completely unchanged, while also offering a new reaction pathway for the chemicals to react. It gets in there, plays around a little, and then hits an Irish goodbye one time when its work is done. Usually, catalysts are used to speed up a reaction rate, but sometimes you gotta take things slow. Look around, enjoy yourself, smell the roses, as they say. And that brings me to the reaction I present to you today: elephant toothpaste. This experiment requires hydrogen peroxide, dish soap, food coloring, warm water, and yeast. The reaction taking place is the decomposition of hydrogen peroxide. It starts life as an H2O2 molecule and then naturally forms water and diatomic oxygen. It looks like this. This process is pretty slow and can take a few days. Thus, using a catalyst can speed up the reaction rate. In this case, that will be our activated yeast. We're going to use the dish soap to capture the oxygen gas, and with all of it being released so quickly, it's going to make a lot of bubbles, aka elephant toothpaste. Yeah, rise! Rise like my bread! Fun fact, this reaction is considered exothermic. It's called that because the decomposition of hydrogen peroxide releases energy in the form of pure heat. What that means is that some of the kinetic energy from the molecules that were clipping around got turned into pure heat, which was then transferred to everything surrounding the reaction. I think that people should have a general understanding of chemistry. Above all else, it's for safety reasons. Generally speaking, most over-the-counter materials are safe for use, except for things that you can't ingest. I think that it would also increase awareness for people in regards to like what they buy day to day at the grocery store or even the medicine that they use. Thank you for watching. If you made it this far, I'm very grateful. This has been my 1051 bonus assignment for Barry Powers' class in fall of 2023. I hope you enjoyed. Have a good one.